Assalamu alaikum students. We continue exercise 1.1 with question number 3, in which we are required to solve the given quadratic equation by the method of completing square. We already learned few important steps to solve quadratic equation. Let's recall these steps and solve this question by completing square method. In first step, we divide each term by quadratic coefficient 7. 7x square divided by 7 plus 2 over 7 x minus 1 over 7 is equal to 0. 7 is cancelled by 7. We have x square plus 2 over 7x minus 1 over 7 in that step. In the second step, we take minus 1 over 7, the constant term, to the right hand side, taking constant term to right hand. We get x square plus 2 over 7x is equal to minus becomes plus when we take it to right hand side. If we do not have 2 in linear coefficient, to make this expression a perfect square, we have to multiply or divide the linear coefficient by 2. But in this case, we have 2 in numerator, so we extract it, extracting 2 from linear coefficient. We have x square plus 2 into x, and the leftover is 1 over 7. When we take 2 out of numerator, so we left 1 in numerator, and in denominator we have 7, so we left 1 over 7 as the second value for a perfect square. To make this expression a perfect square, we need the square of 1 over 7 in the left hand side to be added. So in that regard, adding square of 1 over 7 in both sides, we have x square plus 2 into x into 1 over 7 plus 1 over 7 whole square is equal to 1 over 7 plus 1 over 7 whole square. Now the square is completed. We apply formula to represent this left hand side into a perfect square. Applying formula on left hand side, a square plus 2ab plus b square is equal to a plus b whole square. X plus 1 over 7 whole square is equal to 1 over 7 plus 1 over 49. The square of 1 is 1, whereas square of 7 is 49 in the right hand side. We take LCM on the right hand side, that is 49, 7 7s are 49, 7 1s are 7, 49 1s are, and 1 1s are 1. We have 8 over 49 by taking LCM on the right hand side. X plus 1 over 7 whole square we carry on the left hand side. As we are required to find out the solution, it means we have to find the value of x. For this, we have to remove the square. So hence we apply the inverse property, that is taking square root of both sides. As we take square root of left hand side, we have to take the square root of other side as well. So by taking square root of both sides, we get x plus 1 over 7 whole square root is equal to 8 over 49 square root. Square is cancelled by square root in the left hand side. We get x plus 1 over 7, and in right hand side, as we know that under root 8 is equal to 2 2s are 4, 2s are 8. A pair is formed, so we get 2 under root 2 for under root 8. Whereas 49 square root is equal to 7 into 7. So hence we have 7 under root 49. We replace these values, 2 under root 2 over 7 plus minus as we take the square root of a real number. Now we shift 1 over 7 to the right hand side. So we get what? X is equal to minus 1 over 7 plus 1 over 7 is taken to the right hand side, becomes minus 1 over 7 plus minus 2 under root 2 over 7. Now we take the LCM of the right hand side. As denominators are same, we use the simple standard procedure of taking LCM, that is common denominator and numerator is written as they are, minus 1 plus minus 2 under root 2, and hence the solution set is minus 1 plus minus 2 under root 2 over 7. Let's solve the part 2 by completing square method. For this, we divide each term by quadratic coefficient. A. We have a x square over a plus 4 over a x minus a over a is equal to 0. A is cancelled by a in quadratic term as well as in constant term. A is cancelled by a. We have x square plus 4 over a x minus 1 is equal to 0. In the next step, taking constant term minus 1 to right hand side, we have x square plus 4 over ax is equal to 1. As we already discussed in the previous question, we have 2 in the second term for perfect square. So we extract it, and if we do not have 2, we multiply and divide the linear coefficient by 2. But in this case, we have 2 factor in numerator. So hence, by extracting 2 from linear coefficient, we have x square plus 2, the value x into, when we extract 2 from 4, we left 2 in the numerator and a in denominator equal to 1. For expression in perfect square, we have first 2 terms completed, but the third term is the square of the 2 over a for this expression. So hence, by adding square of 2 over a in both sides, we have x square plus 2 into x into 2 over a plus 2 over a whole square is equal to 1 plus 2 over a whole square. To make the expression a perfect square in the left hand side, we apply formula. Applying formula on left hand side, and that is a square plus 2ab plus b square is equal to a plus b whole square. We have x plus 2 over a whole square in the left hand side equal to 1 plus the square of 2 is 4 and square of a is a square in the right hand side. By taking LCM of the right hand side, we have a square. A square is divided by 1 in denominators, we have a square. A square 1 is a square. A square 1 is a square, 1 4 is 4. So hence we got the LCM. Now, as we are required to find out the solution, it means we have to find out the value of x. So therefore, we have to remove the square by taking square root of both sides. We have x plus 2 over a whole square root is equal to the square root of a square plus 4 divided by a square. Square is cancelled by square root. In the left hand side we have x plus 2 over a, that is equal to plus minus numerator is written as square root of a square plus 4, as it is the sum of the two values, and the square root of a square is equal to. In the next step, we shift 2 over a to the right hand side. We get minus 2 over a plus minus under root a square plus 4 over a. X is left on the left hand side. In the right hand side, denominators are same. We use the standard procedure of LCM, and that is a is LCM and numerators are written as they are, a square plus 4. Hence, that is the solution set. Minus 2 plus minus under root a square plus 4 over a. That's it for the part 2, and we find the solution of the given quadratic equation in that part. Thank you.